Good morning everyone, my name is Aarti. My teammates include Sakshi and Yatharthanand. And today we are proud to present our operating system laboratory project entitled Disk Force Pro Disk Scheduling Simulator. Let's have a quick overview of our project. In the operating system, the disk has to shift, move frequently to read and write data from different cylinders. This movement is known as seek time, and reducing seek time is very important for better system performances. The main objective of our project is to create an interactive visual stimulator that demonstrates the popular disk scheduling algorithms, which include first come first search, shortest seek time first, scan, which is also known as elevator's algorithm, and C-scan, which is the circular scan. User can input their own request queues and change the initial head position and even modify the disk size. The simulator then shows how each algorithm works with animation and provides a clear comparison between them. Now I hand over to Yatharth, who will explain you the working of all four algorithms with a proper demonstration.
Thank you, Aarti. Good morning, everyone. My name is Yatharthanand. Now, I will explain the 4 disks scheduling algorithm we have implemented in our project. In very simple words, we have 4 scheduling methods: FCFS, SSTF, SCN, C-scan, in which first is FCFS, whose full form is first come, first serve. This is the simplest and most basic algorithm. It works exactly like a normal queue. It serves the request strictly in the order in which they came. There is no intelligence or optimization. Because of this, it often results in higher seek time. The scheduling methods. Second one is SSTF, whose full form is shortest seek time first. This algorithm is smarter than the FCFS, first come, first serve. Here, at every step, the disk head looks at all pending requests and moves to the one that is closest to its current position. This helps in reducing unnecessary movement of the head and usually gives better performance. We have the third algorithm, which is scan. It is also known as the elevator algorithm, this one. In this algorithm, the disk head moves continuously in one direction and serves all the requests it finds on the way. Once it reaches the end of the disk, it reverses its direction and serves the remaining request while coming back. It works very similarly to how an elevator moves up to the top floor and then comes back down. Now after that, we have a C-scan, which is also known as circular scan. C-scan is a modified version of scan. Here is the head moves only in one direction. When it reaches the last cylinder, instead of reversing, it jumps back to the first cylinder 0, and then continues solving the remaining requests. These methods provide more uniform waiting time for all requests. Now let me show you a quick live demonstration. Here we can see on the screen on the left side, we have ranking wise all the methods. As SSTF has the least seek time, so it is on the top, and the FCFS has the highest seek time, so it is on the last. After below it, we have also the comparison performance comparison. Here it is shown as a bar chart. Here we can all compare all the methods, and this is my simulation part. Now I will pass it to Sakshi, who will explain the result, observation and conclusion of the project.
Thank you so much, Yatharth, for explaining us the implementation. Now I will be telling you the results, observation, and the final conclusion of our project. So, I will also be telling you some of the features of our project first of all. So you can see a four colored card at the top, which shows us the total seek time for each algorithm. And then we have a real-time line chart that visually shows how the disk head move for all 4 algorithms at the same time. And then we have a detailed output section which shows the complete sequence of head movement, total seek time, and every seek time for every algorithm. And then we have a ranking section which automatically ranks the algorithm based on their seek time from best to worst. And then we have a bar chart for easy visual comparison of performance. And now I will be telling you some of the observation which we have drawn from our project by testing. So the very first thing we have observed is that the shortest seek time first usually gives the lowest seek time in most cases. So this happened because shortest seek time first always selects the request that is closest to the current head position. So the disk head moves the minimum possible distance at each step, which reduces the total moment, and therefore the overall seek time becomes very low. And the second thing we observed is scan and C-scan perform much better than first come first serve. So this is because in first come first serve, requests are handled in order they arrive, without considering their positions. So because of this, the disk head may move back and forth unnecessarily, increasing the total seek time. And the third thing we observed is that C-scan behaves differently because it jumps from end of the disk to back to the goal and back to the beginning. So once it reaches the end, instead of reversing the direction like scan, it jumps back to the is starting point and continuous serving requests. That's why it is called circular scan, C-scan. Okay, so now I will be telling you about the tools and technologies which we have used. So to build this project, we have used HTML, CSS, JavaScript, and for charts and animation, we have used chart.js library. And finally, I would like to conclude our project. So this project has helped us understand the practical working and efficiency of different disk scheduling algorithms in a visual and interactive way. And it clearly shows the advantages and limitation of each algorithm. And thank you so much, ma'am, and everyone for watching our demonstration. And we would be happy to answer any question which you may have. Thank you so much.